WAEC past questions from 2010, physics most especially, physics WAEC past questions, 2010. So I have some questions here. We're going to be dealing with, first of all, starting from the objective questions. So starting from the objective questions, we have the first question here that says, which of the following properties of a long steel bar would alter if the bar were melted, recast into a cube, and allowed to cool to its original temperature? Okay, so this question is quite easy but controversial. So A says density, B says volume, C says specific heat capacity, D says electrical resistance. Now, if you check the questions very well, it said the steel bar has to be melted and recast into a different shape, cube, and then allowed to cool. Now, no matter how a steel is dealt with, it doesn't change its density, it doesn't change its specific heat capacity, it doesn't change its electrical resistance. The only thing it changes is volume, because at first the bar would be rectangular bar, and when it is recasted, it is recasted into a cube. So you are solving the volume of a rectangular bar, you are solving it with the formula for the volume of a rectangle. But for that of a cube, you're probably going to start finding it with the volume of a cube now. So something have changed. So it's the volume actually. So the answer is B. The volume changes. Now number 2, which of the following instruments is the best for measuring the diameter of a thin Constantine wire? A says calipers, B says meter rule, C says micrometer screw gauge, and D says vernier calipers. Alright, so the only thing you can use here is the micrometer screw gauge, not the vernier caliper. Vernier caliper is used to measure the internal and external diameter of any object. Then caliper is also used to also measure the external diameter. And then meter rule is used to measure length. So all those ones are out. The option answer here is C. Number 3, I asked to find density first of all. What's the density of a fuel of relative density days? So the relative density of fuel is 0.72. Now they gave you density of water as 1000 kilogram per meter cubed. Now relative density, as it is, the formula for relative density is the density of the liquid you are comparing all over the equal density of water. So relative density is density of fuel, because fuel is the liquid you are comparing. So density of fuel, then all over the equal density of water. So you say density of water. The best thing to do here is to substitute. So relative density is 0.7. So we have 0.72 here, equal to our density of fuel is not given. So that's what we are looking for. All over equal density of water. Density of water here is 10,000. So we can cross multiply, so that density of fuel is equal to 0.72 times 1000. So that will give us 720 kg per meter cube. Now let's see where what option is the answer here. So we have the first A is 72 kg per meter cubed, of course not the answer, and B we have 720 kg per meter cubed. 720 is the answer, so B is the answer. Number 4, the types of motion which a cylindrical drum rolling down an inclined plane undergoes are. Now a cylindrical drum that is rolling down an inclined plane will certainly undergo 2 types of motion, and that will be translational motion and rotational motion. But let's see what options are available here. Now we have circular and translational. Circular and translational is wrong. It's not circular, it's rotational. Then we have rotational and translational motion. Yes, so the answer here is B. Number 5, which of the following statements about a moving particle is correct? A says, if the resultant force acting on the particle is 0, then it is in dynamic equilibrium. B says, if the resultant force acting on the particle is greater than 0, then it is moving with a uniform velocity. C says, the rate of change of its momentum with time takes place in the direction opposite to that of its motion. And D, lastly, says, the particle falling freely covers equal distance in equal time intervals. Okay, so the correct option here is A, because an object is said to be in dynamic equilibrium if all the forces acting upon it is equal to 0. A is the correct answer. Number 6, which of the following statements about static friction is correct? Static friction. A, it is independent of the nature of surfaces in contact. Now, static friction is not independent of the surface it is acting on, because friction becomes high when the surface is rough and becomes low when the surface is smooth. So it's actually not independent, it is dependent. Now, B says depends on the area of surfaces in contact. Yeah, no, it doesn't depend on the area of the surface in contact. It doesn't depend on the area. The area might be large, the area might be small. Friction still remains friction. So it doesn't depend. So B is incorrect as well. C depends on the relative motion between the two surfaces in contact. Yes, it actually depends on the relative motion between the two surfaces in contact. Depends on the weight of the moving body. Doesn't depend on the weight of the body. So the correct answer here is C. Now, number 7, two cars X and Y traveling in opposite directions along the same highway at uniform velocities these 110 km per hour and 90 km per hour respectively pass each other at a certain point. The velocity of X relative to Y at the time they pass each other is what? Now, for relative velocity, for objects moving towards the same direction, if they are moving towards the same direction, you subtract their relative velocities, their velocity. But if they are moving in opposite direction, you add their velocities. That will give us relative velocity of that body as 110 as 110 kilometer per hour plus 90 kilometer per hour. That will give us a total of 200 kilometer per hour. So the relative velocity, the correct answer is 200. So let's see which is the correct answer. That's option A. Number 8, the average speed of an object is determined by dividing the sum of its initial and final speeds by 2, only when the acceleration is uniform. Now, you can only do that division when the acceleration is uniform. So the correct option is B. Now, for number 9, a body is projected horizontally from the top of a cliff, 45 meters above the ground. If the body lands at a distance 30 meters from the foot of the cliff, calculate the speed of projection. They gave you G as 10 meters per second square. So I would like to draw this. If this is the cliff and the object is, and this is the horizontal floor, and the object is thrown from the cliff, it lands on the floor. The top of a cliff, 45 meter, 45 meter high above the ground, 30 meter from the foot of the cliff. So this is the foot of the cliff. So from here to here is 30 meters. He now said, calculate the speed of projection. Now, the speed of projection definitely would have been straight away like this, but since it is a projectile, the velocity changes as it's moving down. So the velocity will keep changing. Now, the speed of projection is u, which is initial velocity. It is not given, but note that at this point, v is equal to 0, and you have been given g as 10 meters per second square. So the first thing to do is to look for where we have distance in relation with the motion formula. Since this guy is coming projected horizontally, it goes against